Okay, I've got a two-stage refrigerator here with ammonia as the working fluid. Notice that there are two evaporators here, okay, and they each have their own QN. One's 5 tons and one's 10 tons. Okay, a lot of stuff up here, saturated, blah, blah, blah. I put in a lot of these already into the table. Notice that there's an isentropic efficiency on each compressor of 80%, okay? So what I'm going to go through and do is, let's just start at the beginning. So at state 1, I know that I have saturated vapor at 18 psi entering the compressor. So let's go ahead and look up H1 and S1. Again, because I'm going to, across this compressor, I have to do isentropic efficiency stuff on this. So 18 psi, okay, saturated is going to be 604.4, and S is 1.3775. Okay, so that is 604.4, and S is 1.3775. Again, isentropic would make S2 3775. Now that's not actually what it is 80% of that, but I'm going to use this to calculate that. So for the ideal case, 70 psi and 1.3775. Okay, I go into the 70 psi right here, and 1.3775 is just a hair above right here, so I don't know, it's like 683, something like that, 683.72. Okay, 60. Again, that's the ideal case. Now, in actuality, I'm not there. Okay, remember that the compressor efficiency is going to be, excuse me, it's going to be H2S minus H1 all over H2 minus H1, right? From this, I can calculate what the actual H2 is. Again, knowing 80%, knowing the ideal case, knowing the initial condition, all that good stuff, and I get 703.55. Okay, now we're going to skip ahead. We're going to come back to 3 and 4, the second compressor, in a little bit, because I know a lot of the stuff about 5, 6, 7, and 8. Okay, so 5, 6, 7 all have the same H value, right? Because it's just cross expansion valves. Okay, and what I know is that coming out of the condenser, I'm saturated liquid at 200 psi. So let's go grab that H value and plug it in everywhere. So at 200 psi, okay, my H value is 150.73, okay, and that's across all of these. Okay, again, I know I've got the saturated liquid here, okay, but then, oops, 150.7. Again, I'm just going across expansion valves at each one of these, so it remains constant for all of those. Now, the other thing I know is that I've got saturated vapor coming out of the evaporator too. It tells me that in the problem statement, so I can go look up H8, knowing 70 psi saturated vapor. Okay, so I'll go 70 psi, right? Saturated vapor gives me 621.74. Okay, so I've got most of these guys. Okay, I'm just again looking at what's going on at H3. Now, to figure out H3, okay, what I've got here is I know H8 and H2, right? These are mixing. They're all at 70 psi. Okay, so I figure out how they mix. You know, Q in has to equal Q out, or H in has to equal H out. Okay, so in order to do that, first I need to find the mass flow rate. So I'll find the mass flow rate through evaporator 1, mass flow rate through evaporator 2, because again, I know the heat transfer into those. Okay, so for example, Q in 1 is going to equal the mass flow 1, again, times H1 minus H7. So from that, I can find the mass flow rate through evaporator 1 to be 2.204. And that's going to be pounds mass per minute. Okay, I'm going to do the same thing for Q in 2. Okay, this time I'm going to call it the mass flow rate of 8. Okay, so the mass flow rate of 8, okay, is going to be 6 minus 8. I'm sorry, 8 minus 6. And from that, I can find that the mass flow rate at 8 is going to be 4.246. Now that I have those mass flows, okay, now I can basically say that, okay, mass flow of 1 times H2 plus mass flow rate of 8 times H8 equals the total mass flow, right, because conservation of mass holds here. So that's going to be the mass flow rate of 1 plus the mass flow rate of 8 times H3, right? So it's basically H in equals H out, right? Which is what I have there. So from this, I can then find H3, and I get H3 equal to 649.69. Okay. Now I have to do the same thing with the compressor. So the first thing I need to do is go look up S3 so that I can set it to S4S. From that, find H4S. From that, find H4. Okay, so let's go look up H3. So I'm at 70 psi and 649 approximately. So I'm above this. So I'm over here, 70 psi, 649. Okay, so I'm just above 80 degrees, it looks like. I'm at 1.3179 when I do the interpolation for S. So this is 1.3179, which again equals the ideal entropy across this compressor, which is going to be 1.3179. Now using that, I'm going to go look up the ideal H. Okay, 1.3179 is a little above this. That means my H is, what is it? 720.82. That would be the ideal H when I do the interpolation. So that's going to be 720.82. And then similarly to what I have here, I have that compressor equals H4S minus H3 all over H4 minus H3. From that, I find my final enthalpy, which is H4, which is going to be 738.6. Okay, now I'm out of space. I'm going to pull in another sheet of paper here. Okay, but I've got all my H values here. Okay, so what am I looking for? I'm looking for the power input of each compressor. Okay, well, that's nothing more than the mass flow rate times delta H. So, for example, compressor 1 is going to be the mass flow rate of 1, which I know. Okay, and that's going to be H2 minus H1. Which, with all the conversions and whatnot, I find is equal to 5.15 horsepower. Do the same thing with compressor 2. Again, that's the total, right? These have now come together, so it's the total mass flow. So that's going to be the mass flow rate of 1 plus the mass flow rate of H8, equals H4 minus H3, right? Because again, it's the total mass flow going through here. So again, I know H4 and H3, and I get 8.9 horsepower necessary to drive compressor 2. The final thing that it's asking me to solve is the coefficient of performance, which of course is Q in. Of course, I've got 2 Q ins, so Q in 1 plus Q in 2, right? Because these are the 2 outputs, basically. That's what I'm trying to accomplish. All over the total work, which is compressor 1 plus compressor 2. Okay, and make sure you get your units right, but after you do that, you find a coefficient of performance of 5.03. Okay, so there's a refrigeration using several or a couple of evaporators, a couple of compressors, okay, to go ahead and solve that out. But the idea is the same. You just got to find your H values, and then a bunch of delta H's give you the answer.